In honor of Pi Day, which was last Tuesday, March 14th, or 3.14, I thought I'd try to calculate pi without measuring the dimensions of a circle. We all know that pi is the mathematical constant that seems to go on forever, but most people shorten it to 3.14. Now, we don't really know who discovered this relationship, but the accurate calculation is said to be done by Archimedes, who measured the circumference and diameter of a 96-sided polygon to come up with a close approximation. I'm going to use a pendulum. So let's try to draw out this pendulum. First, we have our rod. Now we have our wire, which is going to be connected to a mass. Now, the angle here we're going to be calling theta. So there are a few forces acting on this mass. There's mg, the force of gravity. That has an angular component, and our horizontal angular component we can say is mg sine theta. This is also known as the restorative force, or the force that brings the mass back to the center. We also have the force of tension acting on the system. So let's write this out. We are going to just be dealing with the restorative force in order to find pi, and so again that's mg sine theta. And we can approximate that as just negative mg theta, assuming that our angles are going to be very small. We also know that F is equal to ma. Just from our physics class, that's mass times acceleration. Setting these two equal to each other, we can say that negative mg theta is equal to ma. Reducing that sum, we can say that negative g theta is equal to a. We also know that theta is equal to y over L. So that if we draw out our line again, you can see we have theta. Now the length L is the angular length of the wire, and then y is the horizontal length. Now we can say that negative g y over L, again substituting for theta, is equal to a. A is also equal to negative omega squared y. That's the angular velocity, is omega. Now we can equate these two because we know that acceleration is equal to acceleration. Omega in this case is equal to 2 pi over t. So the angular velocity is 2 pi over the period. Now we can do a little bit of substitution. And substituting in omega and rearranging a little bit, we get square root of g over L is equal to 2 pi over t. So pi here is equal to 2t over 2 root g over L. Now, that is what we're going to be using to calculate our pi. So now let's bring out the pendulum. Here you can see is my fancy little pendulum. I'm going to be measuring up the myDAQ. And this is how it's going to work. So let's jump into software. Okay, so now we've got our software, and here I just have a little graph of light intensity, and let's measure the pendulum length to get an accurate representation of the, and that is about 9 centimeters. So good, I already have 9 written in here. Now all I need to do is start this going. So I have to start it at a relatively low angle, and let's start the program. And here we go, we've already started getting our pulses. So there's a mirror at the bottom of that pendulum, which is reflecting a light down from that LED onto a little photodiode that's sensing a pulse and sensing each pulse. So here you can see we're so close to 3.14. And you know, there are some inefficiencies in the system that are potentially causing this, but I'd say we did pretty well here, getting around 3.15. So this is just one different way of measuring pi that you just don't normally see.